Good afternoon, everyone. We will be presenting our predictive bed allocation algorithm for the Symphony Health Hacking competition. Our motivation for this project is to reduce elective surgeries that were conducted during COVID times, the surgery delays, and limited ICU beds in the States. Our problem definition first begins with a problem statement of the restricted ICU beds and the delays that they incurred. The need statement we identified was a rapid data-driven ICU bed allocation based on COVID and elective surgery bed loads. Our potential for impact can reduce these elective surgery times, and our use cases for both state level and hospital level implementations.
So what we built was a predictive bed allocation algorithm, and it's kind of built into two components. One, which is a predictive model that calculates or predicts the COVID casing for the incoming week based on previous historical data, and then an allocator system that optimally allocates beds to patients with the most need. So the way that we built the decision tool is the prediction model is a simple neural network. So we trained it on 3 weeks of previous data. So it takes 3 weeks and then shoves it through a model and then outputs the current case load for the next week. From this, we plug this into our decision tool, which is our bed allocator, and it takes multiple inputs. The first is the prediction of the cases for this week. And then next is the current demand for surgery. And from there, it takes into account urgency parameters defined by the doctors performing the surgeries, which will then be used to allocate beds optimally using a fast, greedy strategy. And to show the demonstrates, we did a comparison on the California case data for one particular elective surgery. So we see that the blue line is the projected number of cases we should be completing in that week per week. And then the yellow line is what actually got produced in 2020. And then you can see our green line is the algorithm, what we allocated based on the current COVID level, which is the red line. And we can see that we are able to ignore the preemptive dip and only dip when we're at peaks, which essentially improves our bed allocation. In summary, we looked how can we better allocate beds based on a data-driven method, and our particular solution leveraged this new model that we generated as well as different information from healthcare professionals. And our final outcome was a system that could more effectively allocate surgeries efficiently.